Welcome. In this lecture, we are getting to quite an exciting milestone. We're actually going to end up with the tank being able to rest on its own suspensions, as you can see here. It is sitting on these blocks, which are the suspension, and if I go an F8 out of here and lift the tank up, you can see the suspension drops down, and it just lands nice and softly, absorbs the shock of impact, and all that good stuff that we're expecting from a suspension. So we're going to figure out how to put this last piece of the puzzle for getting suspension in this lecture. Let's dive in and see how it's done. Okay, so we're finally going to attach the tank to its suspension. So the first step here is going to be removing the mass that was previously acting as the suspended mass, because that is the place that the tank is going to take. So let's hop on over to Visual Studio and open up the Battle Tank project, go to the sources, and I'm going to go to the C++ for the sprung wheel. Okay, and then we're going to delete the mass from the constructor, and we're also going to go over to its header file, and we're going to delete the mass from there too, because we don't need either of those. And we can go ahead and build that, because that will take a little bit longer than normal compiles because we changed the header file. Cool, so let's then go and have a look at what we've actually got. If I go over to my spring test bed, I'm going to remove the springs that we don't need anymore, and I'm going to drop a tank into the scene here to be our test tank. Bring it up, hit play. There we go, so it's got a cube underneath it, but it's not of much use because it's not constrained to anything. The constraint doesn't work. In fact, probably something in the output log about it. Constraint, yeah, attempting to join an object between objects that are both static. I suppose that might be its way of saying that it can't be attached to anything. Okay, so what we actually want to attach it to is the root component of the tank. And we know that we can get hold of the tank actor, and from that tank actor, we can get hold of the root component. So if we go to the sprung wheel CPP, you can see we've got this if get attached parent actor. So we would be able to get hold of that root component if we want to. But then what would we do with that? Well, let me introduce you to the C++ way of setting up constraints. It's slightly different because we don't have to do named references, which is nicer. So here it is. It is called setConstrainedComponent, and you basically get hold of your constraint, and then you call this onIt. And what you give it is the two components that you want to constrain. Notice that they have to be uprimitive components. They can't just be any old components. So your root has to conform to being a uprimitive component, which, by the way, the name is a little bit ambiguous, but uprimitive components are ones that are able to simulate physics, basically. So not all root components will necessarily simulate physics, but obviously our tank can, and so it will probably cast to this. So you might want to think about doing that. And then the other interesting parameter here is the bone name. Now this is for things where you have a skeletal mesh, and actually the physics body is a collection of, well, the mesh is a collection of physics bodies, because each of the ragdoll bones might itself have a physics mesh to contend with. So in this case, this is not the case for us. We can use a f name, I think it's called name underscore none, like so. And name underscore none, as you can see here in this fname documentation, you'd have to scroll down to the relevant section. It's also linked in your resources. You can see there is name none, and that is just a constant for basically a null name, a name that basically says don't bother looking for bones. So that is what you're going to have to do. So I'm going to leave that as a challenge to you to set it up, the constraint of the tank root, and see if you can get a nice suspended tank in this lecture. Okay, so let's have a look at the challenge definition now. We're going to suspend the tank. That's going to be your challenge. So first of all, you'll need to constrain the wheel to the tank. Add as many wheels as you like by adding the spawn points. Basically, you want the tank to be nicely supported, so think about how many wheels you need for it to not just to be a pogo stick of a tank, but actually nicely balanced and staying on its feet. What should the wheel mass be? Remember what I said about ratios of mass and how that can cause instability. What should the mass of the tank's wheel actually be? And then think about what should the spring strength be also. So pause the video and have a go at this challenge. Okay, welcome back. So let's give this a shot. So I'm going to go over to Visual Studio and I am going to remove our log message from in here. And the first thing I want to check is that indeed we have got the attach parent actor. So I'm going to do an early return if we haven't, because then I'm going to go on to get hold of hopefully a uPrimitive component. So uPrimitive component is star is going to be the type, and this is going to be the body root, because it's not necessarily a tank we're attached to, it's whatever we're attached to, so I'm calling it the body root. And then we're going to get the get attach actor, and we are going to get its root component. So get root component is the function call. And then we are going to try and cast this to the uPrimitive component. So that's cast, angle brackets, uPrimitive component, like so. And then obviously this could return null if the particular thing we're attached to doesn't have a body root. So in that case, we want another early return. So I'm just going to do an if body root, if not body root, in fact, then we want to return one more time. And then with our body root, we can go ahead and set up the constraint. So that's going to be our mass wheel constraint arrow, and then we're going to set constrain components on it. And we are going to, the first body is going to be body root, then name none, as I alluded to before the challenge. And then we are going to attach it to the wheel, not to this component, but to the wheel, not to this actor, but the wheel. So it's name none again for that bone. So that should have set up the constraint rather nicely. Now, I think this is a little bit ugly to be doing early returns when, for example, later on down here, we might add new functionality in begin play. So one thing I do want to do here is just wrap that up into a quick private function. So I'm going to call this setup constraint, and it doesn't have to take any arguments, and it's going to return void, not soid, void. And we are going to copy that, go over and implement it over in the C++, put in the class : and then the body. So I'm just going to take all of that out, cut and paste into, into our setup constraint, like so. And we need to make sure that we do indeed call it from begin play, because we do still want that to happen. So we're going to set up the constraint in begin play, and that just makes it a little bit more readable as well. So let's go ahead and build that finally, and then I want to check that it's actually working. So we can go over into Unreal and see whether our tank is going to be currently acting like a pogo stick. There we go. So it's got a mass underneath it, but as you can see, the mass just goes ahead and pops straight through the floor. Now, that's probably because of the masses being unbalanced. So, well, first of all, before we go and tweak the masses, I want to go and add some more wheels, because there's no point tweaking the masses until we've got more wheels. So I'm going to go to the tank BP first of all, go over to our viewport so I can see the tank nicely, and I'm going to put it in a, I'd usually put it in the left perspective, but actually the tank is aligned in such a way that the front perspective is actually the side-on view. So I'm going to go and get this spawn point, this first spawn point. I'm going to move it to the top of the front wheel arch, like so. And I'm going to cancel out its Y, because actually it is underneath the left track, so that will align it with the left track. And I'm going to duplicate it. So I'm going to do Control W to duplicate that component, and then I'm going to move it back to the back of the last wheel arch, because I think we only need 4 wheels to get a proof of concept going here. Then I'm going to duplicate both of those components in their relative positions, and I'm going to move them under the right track. And then with both of them still selected, I'll go and change the transform again to 0, so that now if we go over to a perspective view, we should be able to see that the right track has got the spawn points 3 and 2, and spawn points 1 and 0 are on the left track. So we can go ahead and hit save, and we can go ahead and hit play. Okay, so we've got lots of cubes there. They are now reacting very strangely. They're also a bit big, so a little bit of a tweak I want to do there is change the mesh. So let's go and open up the sprung wheel BP, click on our wheel component, and I'm going to change the static mesh first of all. There are 2 cube static meshes. One of them is slightly smaller, so find the slightly smaller one. I'm also going to make this spring considerably less long, because it is crazy long at the moment. Let's go ahead and hit play. So they're a bit of a more sensible distance now, but they're still passing through the floor. Reason for that is that mass difference that I was telling you about. So we need to tweak some of these spring parameters to get it working just right. Now bear in mind that our tank is about 40 tons. So, and at the moment our wheel is only 1 kilogram. So that is a huge mass difference. As I was saying, it really doesn't manage with much more than a 40 times difference. So we're going to go with, say, 1000 for the mass of the wheel. And I'm going to go ahead and hit play and see whether that's helped a little bit. Yep, there we go. Our tank is actually resting on its suspension for the very first time. It's resting a little bit high up in the air, so we're going to have to tweak some more parameters. And also, if we go over to the tank BP, I want to disable any collision on the left and right track, because we're going to allow those to float on through the floor and just allow our suspension to be holding us up. We don't want the tank tracks getting in the way. So I'm going to go to the collision presets, overlap all dynamic for those tracks. And then I'm going to go over to our sprung wheel BP and change the strength. At the moment we've got a very high strength, so I'm going to reduce it by a factor of 10 and similarly reduce the velocity target strength, which is going to reduce the damping. So let's go ahead and hit play now. Okay, so we've got a little bit of a bounce there. It seemed like the right sort of bounce to me. So I've been looking at a lot of spring bounces over the past couple of weeks, and that looks like a good kind of well-damped sort of bounce, so I'm quite happy with that. So what we need to do now is just make that arch just a little bit smaller. So I'm going to bring the wheel closer to the root of its actor, which is going to bring it closer to the root of the constraint. And as you can see there, we've got ourselves something looking slightly better. I'm going to bring it just a tad higher again. This isn't the final form of the suspension anyway, so we'll need to do some more tweaking. But I think we've got ourselves a serviceable looking suspension there for the tank. Let's go ahead and preview it in our level as well. So I'll go over to the battleground level and see what we've got in here. If we go and preview it, okay, we spawned a little bit too close to the ground. I'll bring my player start up a notch. And there we go. We're resting on these blocks that are actually serving as our suspension. And you can see when we get knocked up in the air, the suspension kind of pokes out, very much as if when you lift a car, the suspension lifts up in that similar way. Excellent. So it looks like we have got ourselves a good level of suspension with this tank. I'm pretty happy with that for now, and we're going to go on and make this actually polished and look like a tank that can move over the terrain very much like before, but without the glitches. So pats on the back all around, and I will see you in the next lecture.